I'm going to just present very briefly some addition that we had added to Mathematica through the last few versions, mainly regarding how to deal with the image metadata, which is something that we were like seriously lacking upon before. And now we have, I would say, like pretty good way to deal with the standard EXIF metadata, and something which is not here but is coming. And I mean, I can promise it's coming because I saw a merge branch this morning. Is XMP metadata in images. And then I'll show you a bit how to use just a teaser about how to use our machine learning tool to dig in your image collections. And a teaser because Matthias, my colleague, will have a talk like only on that later on. So I seriously invite you to go there. And lately, I just demo a few addition that we have in this version. We are going to have in the next version in our computational photography suite. So let's start. Okay, so is it big enough, the text? Last backline? Bigger? Let's try 150 then. Okay. So just not to be too dry, I decided to use pictures from my Armenian trip. We had a summer school in Armenia that was very nice this summer, and I took some pictures, just with my phone, unfortunately, because my camera was not there with me in Armenia. But still, I tried to take pictures everywhere and add some metadata to that. So just in order for this talk to work. And it's not a huge collection, but you can see, yes, do evaluate, please. You can see is like almost 600 images, and if you like, it's standard phone images. So is you see one image is like 13 megabytes, and if you check like the full amount of this collection is like roughly 1 gigabyte. So you really, if you just want to look, for example, like information attached to images, and I'm like, this is just a stupid travel example, but like there are a lot of microscopy images, astronomy images that have like a lot of information stored in the metadata, and you don't want to import all of them just to check what's inside. So the way we do that now is we have a powerful EXIF importer, and which is much faster actually than importing all the images. And what's going on here, if you do, okay, it's not super fast, but it's still faster than importing it. Okay, so what's going on, this will just look into the image and create an association with all the properties that are stored in the EXIF tag. And this supports like every standard EXIF tag. And I don't know, Shadi, do we support custom tags right now or not yet? Not yet, okay. You can then like dig through these and say, like, for example, like this is just one random image from the collection, and so you can like easily see like this is only one form, but like imagine you have like multiple cameras, multiple devices. You can check the device, you can check like when the picture was taken. If you have like GPS information, I don't know if this one has specifically. No, let's try another one. No, has to be a bit more than 39. Yeah, this one has. So this has like all the GPS information, latitude, longitude, altitude, timestamps, and of course the normal photography properties, like you can see aperture, you can see if a flash fired or not. And by the way, this is like, I don't know if you noticed, we had this dataset container, and the interface for this has been refreshed in the latest version, so you can navigate more easily into like you can navigate into nested association, like inside the dataset, and go back very easily and copy files. So like this is also a nice way to navigate into that. And of course, you can only extract the properties you are interested in and deal with that. So let's see now a bit. I have like some kind of like sample analysis to show what you can do with that. So I said photography. So one thing you can definitely check upon is the exposure time of your picture. And so like, for example, like if I want to see like at glance what kind of distribution I had for my pictures, I see like this is the logarithmic distribution of my exposure times. So I see that like most of the pictures were like probably in daylight condition. But some of them, I visited some monasteries. I didn't took many night picture, but I was into churches and things. So like some pictures were like with a greater exposure value, so you have another peak. And of course, like what's the benefit of using Mathematica to do that analysis of like for these kind of things? You can use like Lightroom, but the point is like, as I say, like you had not only photography that can, like, not only photo cameras that can generate pictures. You have like a lot of scientific data, and with Mathematica you can build the tools yourself. So with a lot of like normal photography software, you have either to rely on one specific set of features, or like it's very difficult, like some plugins you have to look for. Like here, for example, I don't like the histogram, and I very quickly can build like a pie chart. So this one here, for example, will take all the exposures and put them in a pie chart. But like some of them, like these are too many. So I can just easily put a parameter here and change my visualization function to dynamically visualize like the most common exposure times that are in my picture collection. And this is very neat because like you can, if you have to build a report, or like if you want to look yourself at the data and mean for analysis or anything, you can very easily customize, like integrate. This is all integrated in our technology stack, so you can use the visualization function, or I will show some geographics data, or you can do analysis with this thing. It supports quantities. If you notice, like we took some care into like here already, for example, like the exposure time is a time, so it's given in seconds. So this natively works with all the date plot and all the like things in the language that support times. And of course, like once you are done, you can like again very easily like map your own visualization function on the data set, and you can create like in a few lines like a report. So like this is more or less what I did with my picture. Focal length is not so interesting because the phone has only one possible focal length, so I cannot move the lenses. And of course, like for example, these are just the most common ones, but like here I just added one simple flag to see like the percentage of like other that like I excluded before. So like if you're not satisfied, it's very easy to like, for example, like here the difference is like just one line or two lines of code. Like I can like vary the way I visualize the data, I exclude, include data. And this is something that I did for our website, which doesn't show very well because can you read the text? I don't know. Okay. Unfortunately, given I only have one phone and one image collection, it wasn't so interesting, but we could use a Flickr account and analyze that, and this was produced with like 3,000, 4,000 or 5,000 pictures from a Flickr account over the years. And for example, like this is a plot of the percentage of picture taken with the given lens. So, and this was like, okay, a bit more than 2 lines of code. I cannot show it here because I don't have a picture now on this laptop, but you can be like as refined as you want in your basically your visualization. So I mentioned GPS data. So one neat thing is that you can do computation with time. For example, here I can import the datetime tag from the EXIF, and then I have data histogram that like very easily can plot. Like so, these are my trip. I had like 2 weeks. I think it's quite clear. The first 2 weeks I was working. The third week was vacation, and I think it shows. This is, I hope, the weekend. And but we have also other functions like timeline plot is a recent function, and this like different form of visualization that allows you to. If you have like we used to have like we still have date list plot. But that's like a function of time. Here, just like are events in time. So we decided it was a nice thing to have a native built-in way to represent a series of events, possibly with some labels. In this case, I put the images as labels, but it can be anything. And but this is the time part, and there's also the space part, of course. And so here. You see, I can import. Oh, sorry. I'm working with a branch, and there is a bug in the way we do something. So this is going to fix it. I hope. No, one before. Yeah. Oh, yeah, no, of course, this is not going to fix this. The other one is going to be fixed. So, I mean, the point is, like, you can, of course, import from the EXIF tag the latitude and longitude and GPS altitude, but then you have to fix your reference system. Like, if you check the EXIF, we have here, for example, yeah, you see there's GPS latitude and then the reference, of course, because you can be in degree north or south, and also the longitude can be east or west, and the altitude can be above sea level or below sea level. So it gets a bit cumbersome. So we have some shortcuts. For example, instead of importing the EXIF, you can directly import the geoposition. And so this thing here will just convert automatically. We'll just like parse the relevant information from the EXIF tag in the image and create for you a geoposition object. A geoposition object is something that like is smart in a sense. So if I put inside here, for example, this. So you see, this is I don't know if everybody is familiar with quantities, but if I do a full form here, see, this is not a list of numbers, is a list of like numbers with units, what we call quantities. So this is in degrees, and the height is in meters. And if you plug this into geoposition, it will just evaluate a nice compact form with numbers. So you can just use it. I just delete the missing cases here, and I can use it in Geographics. Oh yeah, but here like this is just the raw data. There's like a couple of stray points because my layover was in Moscow, so like there's some extra point. But I'm interested in Armenia, so like now I can like move to another domain, and given that in the Wolfram language we have a lot of like geography information, geography data, geography functions to work with geography data, I can like again very quickly optimize my visualization just to show that this is like the relevant part of my trip. And I can add, there's a tooltip, yeah, it shows. There's a tooltip with like the geolocation, and then I can get creative, of course. Like I have the height, so for example, I can show with a color function, like Armenia is a very mountainous region, so like we went also hiking, and you see there's like some, now I decided to color in black the lowest picture, and then while I move up to the mountain here, like this is like 1,000 meters, but this was a pass. It's like 230. No, sorry, 2030, and this is 3,000. So like again, like very easily you can like play with the color function, like everything you know in Mathematica, and this like is a very powerful way to show information. For like and here I'm not even touching the picture. So just I think like this is a very powerful way like to pull information in and visualize it. And so, okay, now finally we import some images. What I was doing here. Oh, yeah. I have one last, this is like kind of neat. Is again, not strictly image processing, but I like the fact that we can do it. We have this geopath, so I can just show like the pictures like layered on the map with my actual trip. And I was curious, like we drove like 2,000 kilometers roughly. I don't know how much is that in miles, but okay, we can evaluate. So there's 1,600 miles, and we have this function find shortest tour. So I can just put the geoposition in, and this is going to tell me. Oh, I didn't have to evaluate this. Okay, so this takes a bit because there are a lot of pictures, and of course this problem scales badly. So okay, the output of this will be the shortest tour between all the points where the picture were taken. So I can compare my trip with my optimized trip. And okay, the optimized trip is not so bad. Let me check. I was curious about it. So if I do these, let's multiply by 100. Okay, so I could have been like 11% more efficient, but still not so bad. And of course, I can then visualize this on the map. So like, yeah? I have no idea. Wolfram people here. Who's the developer of Find Shortest Path? Which team? Charles Poo? Okay. Okay, I don't have much time, so I'll just move forward. So another thing, okay, this was just for the metadata part. Now we do have some images in. I just imported the thumbnails, but a lot of things are going to work anyway. So here let's see, like, I noticed, like, I mean, in Armenia there are a lot of monasteries, and I took a lot of pictures of monasteries. So let's say now I want to dig into my collection and find the pictures of monasteries, for example, because a lot of other pictures are stupid. There's me, my friends, food, I mean, the usual stuff. I mean, we have a computational engine here, so we should be able to do that. The best thing we could do before was just analyze kind of the distances between pictures. And there are many definitions for that. Like, for example, this is the stupidest. I mean, nearest is a very powerful function. It has a lot of methods inside. But by default, it does like the obvious thing. So when you call nearest with a list of images, you just measure the Euclidean distance between the pixels. And of course, like, if I want to find churches, that's not the best way. So I have better functions, but there are like many problems. Like, for one thing, they are like kind of slower, or a lot slower, because like there's more computation involved. And for example, here I'm using the mutual information, which is measuring the joint probability. So like it does a bit better, but still, so I find few churches. These are just the first 5 images, but this is still very expensive to use, and is not easily applicable to the. I mean, if I want to reevaluate this, I cannot like save either I measure all the distances, but I cannot like save kind of the nearest function is very efficient, but I cannot build a nearest function here and use that again, because like I would have to put in there all the image data, and it will be slow anyway. And the second, the most important part is that this is just looking at the pixel values. It doesn't have like any like better way to represent the images. But now we have through machine learning, and not much time. Okay, so Etienne showed you that we have like, and other people in machine learning, we have like enhanced machine learning capabilities. And those, of course, are like applicable to any data, included pixel values in images. So what I did here is to build a feature extraction function. This, of course, takes a while, but once that this is done, I can apply this to an image and basically convert it to a vector. And this vector is not just like random numbers, like this vector here is like basically maps my image collection into a feature space. And those features are representative of the content of the image. And if you do this mapping, you can do this just by pixel value, but you can also use very powerful deep learning method to obtain those vectors. And they will have built-in classification information. So let me show like practically what does it mean. Like here I'm building a variation of nearest that I think we are going to have soon in the language, which is called semantic nearest. But right now I'm just creating this using a nearest function, and like as a distant element, like the features, and is giving it output the images. So now if I use this on monasteries, I find just churches. And the amazing thing is like these churches are very different. Like the colors are different, but the concept is similar. So this is the powerful part of the machine learning element of this. And let's see, for example, the difference. If I do like the semantic nearest on the monastery, I find like mainly, you see, like there are basically all the images of churches. And if I do just the normal nearest with Euclidean distance, it's something which is similar in color, but it doesn't really have any semantic closeness to the original thing. And then, of course, you have, I think, in the notebook, but we have like more advanced function to show, like to clusterize images. We can do many things. We can build clustering trees. We can collect them in dendrograms. We can find cluster through images, and for example, like these are some image clusters in which I explicitly use clustering function to find groups, subgroups in images. And so, I mean, this stuff is very powerful, but I don't have time to show all of it now. And but the point is, like, all the things that you can use for data is easily extendable to images. And when you have like huge number of images, like, it's nice to be able to automate those procedures. Like sometimes you don't really want to tag every image yourself. Like, so of course, like the human element is essential, but if you can like guide it, and like it's a big help if you have like, let's say 80-90% of the work done by the machine already. So you just have to refine it. The last part is that I wanted to show just because I personally like it, and I'm working on that, is that another thing that we support are like way to deal with image stocks. And Marcus down here is showing is the guy with the microscope, and so he's showing how to deal with like multiple images taken at like same subject, multiple focus planes. Here I have like is very badly aligned because it's just phone pictures, but same subject with multiple exposure levels. And why do you want to do that? Because sometimes you have like, for example, like here, a nice sky, but you have something in front which is dark, and you cannot really see that. So the trick is like to take multiple pictures and then try to merge them together. And this is like, since a couple of versions, it's very easy, and we are still working on that to make it more powerful and more automated. And for example, here just I have to align the picture, and when they are done, I just build a mask to remove the part which is like not aligned. Because of course, like if I show you these different pictures, like the content is moving around because my hand was moving, not so stable. So I can align them and just find the misaligned region. And once that is done, I can just throw it away and then combine the pictures together. So this takes like the best of every picture and combines it together. And this we had like since a couple of versions. This is a nice addition we have. This is fairly new. So we have this method for the function in Paint that generates textures. And this is called texture synthesis that looks into the image. And because I really don't like the fact that I had to cut away part of the image here. So I can just create like another mask using my original mask that I used to cut it. So I say, okay, just look inside the good part, just not too far from the border, and look there and synthesize some textures. So I can basically, you see this part here is new, but it's been filled in with the content of the image that we synthesized. Like, so I go back to the original size, and I can see I'm done. And the very, very last thing that we are working on here, this is like kind of preview, it was just in my build, is that to find a way to, instead of just combining the pixel values in a normal low dynamic range image, is basically to combine everything together. And this image is similar to the other one, but is more spread out in the sense that it contains a lot of information, both in the dark and in the light part of the image. And why do you want to do something like this? Because then you can like manually, I'll just show this one, manually tone map the image. So like basically you can choose yourself how to combine the bright part and the black part, and also for like creative effects or like to show more information in the same image. And I really don't have any more time, much more time, so I'm done. Thank you.